Okay, good day everyone. Let us go back to our discussion on linear programming, and this will be our last part, real-world problems involving maximum value of an objective function. Let us try this problem out. Your club plans to raise money by selling two sizes of fruit baskets. The plan is to buy small baskets for 200 pesos and sell them for 320 pesos. And to buy large baskets for 300 pesos and sell them for 500 pesos. The club president estimates that you will not sell more than 100 baskets. Your club can afford to spend up to 24,000 pesos to buy the baskets. Find the number of small and large fruit baskets you should buy in order to maximize the profit. Okay, so let us start by representations. Let X be the number of small baskets and Y be the number of large baskets. And then our objective is to find the maximum profit, so we represent the profit as P. So if we're going to formulate our objective function, that will be P is equal to 320X plus 500Y. Because each small basket can be sold for 320 pesos according to the problem. Each large basket can be sold for 500 pesos. So if we're going to get the net profit, the resulting value for P will be subtracted by 24,000 pesos, considering that the club was able to spend the maximum amount of 24,000. So our objective function here is getting the profit, gross sales in that matter, for that matter. So let us now formulate our constraints. These are the restrictions that will lead to the attainment of our objective or goal. So let us formulate number 1 inequality. We have x plus y is less than or equal to 100. To formulate the constraints, one method is to tabulate the resources or the given found in the problem. But this time, it is easier to formulate the inequalities because the problem clearly states in here that the president estimates that you will not sell more than 100 baskets. So if x is the number of small baskets and y the number of large baskets, then our inequality will be x plus y is less than or equal to 100. Okay, let's go to the next restriction. 200x plus 300y is less than or equal to 24,000. According to the problem, the president says, or the club can only afford to spend 24,000 to buy the baskets. So if the small baskets can be bought for 200 pesos and the large basket can be bought for 300 pesos each, then the spending or the amount spent by the club will be 200x plus 300y, and this must be less than or equal to 24,000. Okay. Since we're solving for real-world problems, we have additional restrictions, and that these are x is greater than or equal to 0 and y is greater than or equal to 0. So we already have our objective function and constraints formulated from the given problem. The next step is to graph the system of linear inequalities from our constraints. Let us start with x plus y is less than or equal to 100. If we're going to use the slope-intercept method, we'll have the y-intercept as equal to 100 and the slope is negative 1. So plotting the point, the y-intercept is 100, so that will be at 0, 100. And then by the slope, negative 1, that means the number of steps going down, units going down, will be equal to the number of steps going to the right. If we do 100 steps going down, so that will be 100 steps going to the right. So another point will be at 0, at 100, 0. Let us graph the line. So the solution to this inequality, if we use the origin as the test point, then the shaded region will include the origin. Let us proceed to the next inequality, that is 200x plus 300y less than or equal to 24,000. This time, it would not be easy to use the slope-intercept method, so we use the two-intercept method. That is to set the value of x as equal to 0, then solve for y. So x is 0, 200x cancels. Y will be 24,000 divided by 300, y is equal to 80. So we have 1 point at 0, 80. Next, let us set y as equal to 0. So in that case, 300y cancels, that is 0. So x is 24,000 divided by 200, then x equals 120. Then we have another intercept at 120, 0. So we can draw the line and then use the origin as the test point 0, 0. So that will include the test point in our solution. And our feasible region or feasible solution will be shaded. That is the intersection of the two solutions in our inequality, including x is greater than or equal to 0 and y is greater than or equal to 0. So from here, by theorem, the solution to the values of the objective function are obtained, the maximum and minimum values to the objective function are obtained by using the corner points because we have a bounded region in our feasible solution. Let us try to get the corner points for this feasible solution. The corner points will be 0, 0, the origin. Next is the x-intercept of our first inequality, that's 100, 0. Another one is the y-intercept of the second inequality, 0, 80. And we have a fourth corner point at the intersection of the two lines identifying our system of linear inequality. So in this case, it would be difficult to estimate the point of intersection. Then in order for us to identify the intersection, we will use this solution to system of linear equation given by our first two inequalities or constraint, that is x plus y equals 100 and 200x plus 300y equals 24,000. Let's do that using x plus y equals 100 as our equation 1, and let us express x in terms of y. So that will be x equals 100 minus y from our equation 1. Then, since we have an expression for x, let us substitute this to x in our equation 2. From there, we will have 200 times 100 minus y plus 300y equals 24,000. By distributive property, we get 20,000 minus 200y plus 300y equals 24,000. Combining similar terms, we have 100y, yes, that is from 300y minus 200y. And to the right hand of the equation, that will be 24,000 minus 20,000. Let's get the value of y. Dividing both sides by 100, we have y is equal to 40. Now this value of y, substitute to equation 1 so that we will get the value of x. Then that will be x equals 100 minus 40 and x equals 60. Then we have the fourth corner point with coordinates 60, 40. Now that we already have all the corner points in our feasible solution or feasible region, let us go back to our objective function and substitute the coordinates of these corner points in order to get the value for our objective function. Let us start with the first one, 0, 0. So if we substitute this, we have 320 times 0 plus 500 times 0. So the value for our objective function will be 0. Next corner point is 100, 0. So in our objective function, that will be 320 times 100 plus 500 times 0, and that will be 32,000. That's 320 times 100. And 500 times 0 is 0. Okay, let's go to the next corner point, and that is 0, 80. Substituting the ordered pair xy to our objective function, 320 times 0 plus 500 times 80. 320 times 0 is 0, and 500 times 80 is 40,000. Okay, last we have 60, 40. 320 times 60, that will be 19,200, plus 500 times 40, that will be 20,000. Add, we have 39,200. So from here, we now have the possible values for P, our objective function. And since we get the largest value at 40,000, so if we are going to get the net profit, that will be 40,000 minus 24,000, the maximum spending possible, and that is 16,000 pesos. But in this problem, we are asked to identify the number of small baskets and large baskets that the club should buy. So in order to maximize the profit, 0 small baskets and 80 large baskets should be bought. Okay, that will be for real-world problems involving objective function. If you would like to try some written exercises about this topic, please request through email at dalmasio.data@deped.gov.ph or message me on Facebook. That's facebook.com/GCD1974. Thank you.